Welcome! This video is going to explore using the Little Man Computer Assembler to write assembly language code instead of machine code. So the basic idea is that early programmers had to write machine code. It was the only way to write programs for computers. And they didn't even get to use the decimal codes that we get to use for the Little Man computer. They had to do everything in binary. They very quickly realized that this is a pain. It's hard to read a program like this and understand it, even more so if it's in binary. It's also hard to keep track of where pieces of information are, that this 310 links with that piece of memory, and if I decide that I need to expand this program and push everything down ways and move this to a new location, it'd be very easy to do that without and break kind of the existing lines of code. I would have to go in and adjust all of them to point to a new location where they could find this value that they're supposed to look for. So assembly language was an early invention to make machine code more human-friendly. The usual idea for assembly code is it's pretty much a one-to-one correspondence between an assembly instruction and a machine instruction. So the assembly instruction might be INP, which would correspond to the machine code 901, get input. Store first, STA first, might translate to 307. Store value, right? This is 300 is our store, the location is 7, and the assembler looks at this instruction, translates it to the number. The way it can figure out that first is supposed to be 7 is that down later in my assembly I have a note here that says first is data, and it starts with a value of 0. So that gets translated to just a bunch of zeros. But the assembler can do the work of figuring out that this first is the same as that first, and that this address 3007 has to match up with the machine address 7, where the data is actually expected to be. So for each of the machine instructions that we've been dealing with, we have an assembly instruction. We also have an extra one called DAT, which gets used to represent pieces of data. We always give them a name and then specify that it's a piece of data and then the value we want to start with. And we can use a program that will read this somewhat human readable assembly and turn it into the machine code. The program that we have to do that is the online Little Man Computer Simulator. Now you can use this instead of the workbooks, but it is a little bit harder to understand kind of what's going on with it. But a cool thing it does have is an assembler. So if I have a piece of an assembly program, so here's an assembly program, a list of instructions, I just have it in a text editor, and I'm going to copy that and put it in this message box and hit compile program. And it's going to chug, it'll show me kind of what it does, and here's my program. It turned in to 901. Store first, it turned into 306. Another input into another 901. Add first, I can see down here it decided that that is a 100 instruction, and it's going to add address 6 because it sees first here, which is the same as first there. So here's my program. If I want to test it out, I could do it inside this simulator, but I can also take those codes and take that over to my workbook. So I'm going to just copy those, 901, the instructions here go side to side until you get to 10 and they wrap around. So then 306, then 901, then 106, then 902, then 0, then 0. And it looks like my instructions go up to 6. So I'm going to make sure I've got all those in there. And now I've got a program that I can actually run and test out. Couple things to note about the assembler. If you give it stuff that doesn't make sense, so I'm going to clear everything there and replace it. So let's say I say store into second, but then nowhere down here do I specify that second is a piece of data. It's going to die. It's going to start working and then tell me target label second is not valid. Compile unsuccessful. So it wasn't able to turn my program into working code. If you ever see a compile unsuccessful, go double check what you typed in. Other thing to note is that when I hit compile, it wipes out my code. It's still there, but kind of getting it back if I made a mistake is a bit of a pain unless you have it stored in another place. I recommend you use Notepad or any other text editor to write your program, then just copy and paste it into the compiler, into the assembler, build your program, and if it works great, wonderful, you can copy it out and test it out. If something goes wrong, you can double check it, fix up your code, copy, paste it back in, and just use this for doing the compiling. Use a separate text editor to actually store your programs.